Okay, so for this quiz 3, name one method of logic level conversion. Well, there's 3 of them. You could use the chip, or voltage divider, or you could have used the banking. The chip one is really simple. You put a chip in the circuit and you hook it up, and it'll convert the logic level for you. The voltage divider is over here. You have system A and system B. R1 and R2. Essentially, this system is a higher voltage system, and this one's a lower voltage system. If you want to convert it, then you're going to have to use this voltage divider, because V out and V in, V out is equal to R2 over R1 plus R2 multiplied by the V in. Okay. Now the problem with here is you can't sync or source current between the two systems now. It's just the logic level that's being converted. You're going to burn some power on the resistors, and you can only go from high voltage to low voltage in one direction this way. The other method was the banking. In the FPGA banking method, you had, let's say, one side, two side, three side with a core chip at 1.2 volts. You could hook one side or one bank to 1.2 volts, 3.3 volts, 0.8 volts, let's say 5 volts on one side. And then in code, you could just do assign A equals B coming from the 3.3 volt side to the 1.2 volt side. So, the next question is this a common anode or cathode display? Let me just fold it over. It is a common anode or common cathode display. Remember, anode, cathode, the flat side's cathode. So the cathodes are all pointing up towards a common 9 and 6, right? So that means that it's a common cathode. The cathodes are connected together. So the correct answer is cathode. This is opposite from the one we have in lab, which is common anode. You have to use persistence of vision to drive the display. What does persistence of vision mean? Persistence of vision means that you are changing, in this case, the two 7-segment displays on pin 6 and 9, let's say. You're changing this at a speed at which your eyes can't pick up the change. So if you change it fast enough, it'll look like it's constantly there. Okay, so something along the lines of that answer was acceptable. What would the frequency that works for persistence of vision? I accepted anything greater than 60 hertz, but reasonable. If you put 60 megahertz or 100 megahertz, I said no. So anything above 60 megahertz. A lot of people would put 500 hertz, which is good too. Anything less than 60 hertz or so, your eyes are going to be able to distinguish the difference between the two displays, and you don't want that. So for persistence of vision, anything greater than 60 hertz and less than, let's say, 10 kilohertz, I said fine. So this last question right here. Given this 2 7-segment display, please describe and provide the pseudocode on how to drive it so that the numbers 1 and 5 show up at the same time. So, okay. So, 1 is set pin 9 low, right? Anode to cathode. This has to be high, that has to be low for it to light. 6 high for it to not light. Then we do what? The number 1 should be B and C. So B and C should be C equals 1, everything else 0. 3, set pin 9 high, 6 low. to turn off this one and turn on the digit 2. So then for 5, we need this, and this. So that's A, B, C, D, E, F, G. So set A, F, G, C, D low. Sorry, high. Everything else low. Essentially, the first step is to set 9 low, send it to 1, right? Send it to 1, step 2. Number 3 is switch to the second display. Switch to the second display, setting 9 high and 6 low. And then we set A, F, G, C, D, step 4. Set those values high, everything else low to display the 5. Then switch rapidly at a rate that's higher than persistence of vision. Okay?